So, let's talk about something we all think we know how to do: measurement. It seems simple, right? You grab a ruler, you look at a number, and you're done. But what if I told you there's a secret language hidden in every measurement? A language of precision that, when you get it wrong, can have, well, some pretty epic consequences. To see what I mean, we're going to start with a quick trip to Mars. Okay, get this. Back in 1999, NASA shot its Mars Climate Orbiter into space. We're talking a $125 million piece of tech, sent to go study the Martian atmosphere. But as it got close to the red planet, poof, it just vanished. Total radio silence. So what in the world happened? You're not going to believe it. The whole mission failed because of a simple translation error. See, one engineering team was using metric units, Newton seconds, while another team was using imperial units, pound seconds. The numbers got sent from one team to the other, but the units, the of what, got lost in the shuffle. A tiny, tiny mistake that literally caused a spaceship to burn up in the atmosphere. That story just drives the point home, doesn't it? Measurement isn't some boring thing you only do in a lab. It's a critical way we communicate. It's a process where getting the details exactly right is everything. And when we mess it up, things can go very, very wrong. And it's not just about losing spaceships. This stuff matters everywhere. Ever try to bake a cake without measuring the flour? You basically end up with a clay brick. Or what about buying paint for a room without measuring the walls? You're either making a second trip to the store, or you've got a bunch of expensive paint cans sitting in your garage. From your kitchen to the final frontier, getting measurements right is what makes our world work. So, if we want to avoid our own $125 million blunders, we need to get a handle on the two big ideas in measurement: accuracy and precision. Now, they might sound like the same thing, but trust me, in science, the difference between them is absolutely huge. All right, let's break this down. Think of it like a game of darts. Accuracy is all about hitting the bullseye. It's how close your measurement is to the real, actual value. Precision, on the other hand, is about consistency. It's about hitting the same spot over and over and over again, even if that spot isn't the bullseye. To get really good, reliable data, you need both. You have to be right and you have to be consistently right. And of course, no measurement is complete without its other half. This quote says it all. A number tells you how much, but the unit tells you of what. Saying something is 10 long is completely useless. Is that 10 feet, 10 miles, 10 millimeters? Without the unit, the number is meaningless. Just ask the folks at NASA. Okay, theory is over. Let's get our hands dirty. How do we actually make a good measurement? Well, this is where it stops being just about looking at a tool and starts being an art. An art of, you guessed it, reading between the lines. And if there's one thing you remember from all this, make it this right here: the golden rule. For any tool with marks on it, like a ruler or a thermometer, you write down every single digit you know for sure, and then you add one more that you estimate or guess. That last little guess is the most important part. Let's try this out with an old friend, the classic metric ruler. We've all used one of these a million times. Take a look at this bar here. So what do you think? How long is it? What numbers on that ruler are you absolutely certain about? And where do you have to start making your best guess? Let's walk through it together. First, we find the smallest little marks on the ruler. Those are millimeters, which are 1/10 of a centimeter. Okay, next, we read what we know for sure. We can all see that the bar goes past the 7.8 centimeter mark, right? No question there. Now for the golden rule. We estimate one more spot. To me, it looks like it's about halfway to the next line, so I'm going to estimate that as a 5. So we write down 7.85 centimeters. That 7 and that 8, those are our certain digits. We know those are correct, but that last number, the 5, that's our estimated or uncertain digit. And here's the cool part. If you thought it was 7.84 or maybe 7.86, that's totally fine. That last digit is our educated guess, and it communicates the limits of our ruler. Now, measuring liquids has its own little curveball. Literally. When you put water in a skinny glass tube, the surface isn't flat. It makes this little U-shaped curve called a meniscus. And the rule is super simple. You always, always read from the very bottom of that curve. So here we go. A graduated cylinder with some liquid in it. You can see that meniscus pretty clearly. We're going to apply the exact same golden rule. Find the bottom of the curve, read all the numbers you're sure of, and then estimate one more place. The correct reading here is 43.0 milliliters. Now, wait a second. You might be thinking, but it's right on the 43 line. Why not just write 43? But remember the golden rule. We have to estimate one more digit. Since it's sitting perfectly on the line, our best estimate for that next digit is 0. That point 0 isn't just there to look pretty, it's critical data. It tells anyone reading our work that our measurement is so good we were able to estimate all the way to the tenths place. And that little 0 is the perfect lead-in to our last big idea, significant figures. The best way to think about sig figs is like a secret code. It's a code hidden in every number that tells you a story about how good the measurement tool was. Just look at this table. It tells the whole story. If someone tells you something weighs 15 grams, you can guess they probably used a basic kitchen scale. But if they say it weighs 15.0 grams, that extra 0 tells you they used a better tool, one precise to a tenth of a gram. And if they report 15.000 grams, whoa, you know they used a super sensitive, expensive lab balance. The numbers are almost the same, but the stories they tell about their precision are worlds apart. So at the end of the day, significant figures are all about being honest. The numbers you write down are your way of communicating to the world. Hey, this is how good my tool was, and this is how much you can trust my data. It stops us from pretending our data is more certain than it really is. Okay, let's zoom all the way back out. We've been talking about rulers and lab equipment, but I promise you, these ideas aren't just for science class. These are the invisible rules that literally build the world around us. Seriously, think about it. That old saying, measure twice, cut once, that's all about ensuring accuracy and precision. When a doctor gives you medicine, the dosage has to be exact. A tiny error can have huge consequences. A baking recipe? It's really just a chemical procedure for your kitchen. And the phone or computer you're watching this on right now? It's full of microchips with parts so small they're measured in nanometers. Our entire modern world is built piece by piece on a foundation of good measurement. Which leaves us with one last thought. We live in a world that is just drowning in data. Numbers are everywhere, telling us what to think, what to do, what to buy. But how often do we stop and ask, where did that number come from? How was it measured? How precise is it really? The art of measurement reminds us that every number has a story. It teaches us to not just accept data, but to be curious about it. Thanks for tuning in.